A notification system has already become a very popular feature for many applications in recent years. A notification alerts a user with important information like breaking news, product updates, events. It has become an indispensable part of our daily lives. A notification is more than just mobile push notification. Three types of notification formats are there: mobile push, SMS message, and email. Figure shows an example of these notifications. What type of notifications does the system support? Push, SMS, and email. Is it a real time system? It is a soft real time system. We want a user to receive notifications as soon as possible. However, if the system is under a high workload, a slight delay is acceptable. What are the supported devices? Android, iOS, laptop, and desktop. Notifications can be triggered by client applications. They can also be scheduled on the server side. Users who choose to opt out will no longer receive notifications. 10 million mobile, 1 million SMS, 5 million emails. This section shows how the high level design that supports various notification types is structured. Different types of notifications, contact info gathering flow, notification sending and receiving flow. We start by looking at how each notification type works at a high level. We primarily need three components to send an iOS push notification. Provider. A provider builds and sends notification requests to Apple Push Notification Service. To construct a push notification, the provider provides the following data. Device token. This is a unique identifier used for sending push notifications. This is a JSON dictionary that contains the notifications payload. This is a remote service provided by Apple to propagate push notifications to iOS devices. It is the end client which receives push notifications. Android adopts a similar notification flow. Instead of using APNs, Firebase Cloud Messaging is commonly used to send push notifications to Android devices. For SMS messages, third-party SMS services like Twilio, Nexmo, and many others are commonly used. Most of them are commercial services. Although companies can set up their own email servers, many of them opt for commercial email services. SendGrid and MailChimp are among the most popular email services, which offer a better delivery rate and data analytics. Figure shows the design after including all the third-party services. To send notifications, we need to gather mobile device tokens, phone numbers, and or email addresses. When a user installs app or signs up for the first time, APIs collect user contact info and store it in the database. Figure shows simplified database tables to store contact info. Email addresses and phone numbers are stored in the user table, whereas device tokens are stored in the device table. A user can have multiple devices, indicating that a push notification can be sent to all the user devices. We will first present the initial design, then propose some notifications optimizations. Figure shows the design. Each system component is explained below. Notification system, APNs, FCM, SMS service, email service, third-party services. A service can be a microservice, a cron job, or a distributed system that triggers notification sending events. A billing service sends emails to remind customers of their due payments, or a shopping website tells customers that their packages will be delivered tomorrow via SMS packages. The notification system is the centerpiece of sending and receiving notifications. Starting with something simple, only one notification server is used. It provides APIs for services, all the services, and builds notification payloads for third party services. Third party services are responsible for delivering notifications to users. While integrating with third party services, we need to pay extra attention to extensibility. Good extensibility means a flexible system that can easily plugging or unplugging of a third party service. Another important consideration is that a third party service might be unavailable in new markets or in the future. FCM is unavailable in China, JPush are used there. Users receive notifications on their devices. Single point of failure. A single notification server means single point of failure. The notification system handles everything related to push notifications in one server. It is challenging to scale databases, caches, and different notification processing components independently. Processing and sending notifications can be resource intensive. Constructing HTML pages and waiting for responses from third party services could take time. Handling everything in one system can result in the system overload, especially during peak hours. Move the database and cache out of the notification server. Add more notification servers and set up automatic horizontal scaling. Introduce message queues to decouple the system components. Figure shows a high level design. The best way to go through the above diagram is from left to right. They present various scenarios that send notifications via APIs provided by notification servers. Provide APIs for services to send notifications. Those APIs are only accessible internally or by verified clients to prevent spams. Carry out basic validations to verify emails, phone numbers, etc. Query the database or cache to fetch data needed to render a notification. Put notification data to message queues for parallel processing. Here is an example of the API to send an email. User info, device info, notification templates are cached. It stores data about a user, notification settings, etc. They remove dependencies between components. Message queues serve as buffers when high volumes of notifications are to be sent out. Each notification type is assigned with a distinct message queue, so an outage in one third party service will not affect other notification types. Workers are a list of servers that pull notification events from message queues and send them to the corresponding third party service. Already explained in the initial design. A service calls APIs provided by notification servers to send notifications. Notifications servers fetch metadata such as user info, device token, and notification setting from the cache or database. A notification event is sent to the corresponding queue for processing. Workers pull notification events from message queues. Workers send notifications to third party services. Third party services send notifications to user devices. In the high level design, we discussed different types of notifications, contact info gathering flow, and notification sending receiving flow. Reliability, additional component and considerations, notification template, notification settings, rate limiting, retry mechanism, security input notifications, monitor queue notifications, and event tracking. We must answer a few important reliability questions when designing a notification system. One of the most important requirements in a notification system is that it cannot lose data. Notifications can usually be delayed but never lost. To satisfy this requirement, the notification system persists notification data in a database and implements a retry mechanism. The notification log database is included for data persistence. The short answer is no. Although notification is delivered exactly once most of the time, the distributed nature could result in duplicate notifications. To reduce the duplication occurrence, we introduce a deduplication mechanism and handle each failure case carefully. Here is a simple deduplication logic. When a notification event first arrives, we check if it is seen before by checking the event ID. If it is seen before, it is discarded. Otherwise, we will send out the notification. For interested readers to explore why we cannot have exactly once delivery, refer to the reference material. We have discussed how to collect user contact info, send and receive a notification. A notification system is a lot more than that. Here we discuss additional components including template reusing, notification settings, event tracking, system monitoring, rate limiting, etc. A large notification system sends out millions of notifications per day, and many of these notifications follow a similar format. Notification templates are introduced to avoid building every notification from scratch. The notification template is promoted is pre-formatted notification to create your unique notification by customizing parameters. Here is an example template of push notifications. You dreamed of it, we dared it, item is back only until this. Order now or save my. The benefits of using notification templates include maintaining a consistent format, reducing the margin error, and saving time. Users generally receive way too many notifications daily and they can easily feel overwhelmed. Thus, many websites and apps give users fine grained control over notification settings. This information is stored in the notification setting table with the following fields. Before any notification is sent to user, we first check if a user is opted in to receive this type of notification. To avoid overwhelming users with too many notifications, we can limit the number of notifications a user can receive. This is important because receivers could turn off notifications completely if we send too often. When a third party service fails to send a notification, the notification will be added to the message queue for retrying. If the problem persists, an alert will be sent out to developers. For iOS, AppKey and AppSecret are used to secure push notification APIs. Only authenticated or verified clients are allowed to send push notifications using our APIs. Interested users should refer to the reference material. A key metric to monitor is the total number of queued notifications. If the number is large, the notification events are not processed fast enough by workers. To avoid delay in the notification delivery, more workers are needed. Example of queued messages to be processed. Notification metrics such as open rate, click rate, and engagement are important in understanding customer behaviors. Analytics service implements events tracking. Integration between the notification system and analytics service is usually required. Putting everything together shows the updated notification flow. In this design, many new components are added in comparison with the previous design. The notification servers are equipped with two more critical features: authentication and rate limiting. We can also add a retry mechanism to handle notification failures. If the system fails to send notification, they are put back in the messaging queue and the workers will retry for a predefined number of times. Furthermore, notification templates provide a consistent and efficient notification creation feature. Finally, monitoring and tracking systems are added for system health check and future improvements. Notifications are indispensable because they keep us posted with important information. It could be a push notification about your favorite movie on Netflix, an email about discounts on new products, or a message about your online shopping payment confirmations. We describe the design of a scalable notification system that supports multiple notification formats: push notification, SMS message, and email. Besides the high-level design, we dug deep into more components and optimizations. We proposed a robust retry mechanism to minimize the failure rate. App key is used to show only verified clients can send notifications. These are implemented in any stage of notification flow to capture important stats. Users may opt out of receiving notifications. Our system checks user settings first before sending notifications. Users will appreciate a frequency capping on the number of notifications they receive. Congratulations on getting this far. Now give yourself a pat on the back. Good job. Well,